Now I'm going to compare my actual and predicted. I'm going to take this formula that I just figured out for runtime. I'm going to go back to my sheet of original data, and I'm going to, you're not going to have this, but I'm going to put in my predicted runtime, and I'm going to put my formula here just so I have it here to look at that I've written down before. Instead here though I'm going to erase this runtime out of here, and instead of having the age written like this, I have to go to the cell number where age is. Age is in D2, so I'm going to replace this age with D2. And here, instead of push-ups, I'm going to put the raw push-ups they did, which is F2. And instead of sit-ups, I'm going to put the raw sit-ups that I have. That's in J2. So I'm going to put those in there. And then I'm going to hit enter. And that gives me the predicted runtime for that particular value, for that particular inputs. It's not too bad. Like, it's a little bit higher, but there we go. And I drag down that formula, and that gives me all the predicted values from my model that I just developed, which none of it was significant, so it shouldn't be perfect at all. How do I check the error? Well, the first thing I can do is go mean absolute error. Let me put absolute error here. Absolute error. So the absolute error is going to be the difference between the actual and the predicted in absolute value. ABS makes this the ABS makes the absolute value, and then I'm going to take P2 minus Q2, and that's going to give me the absolute error. How much error was there? It was 62 seconds of error for the first guy, about 63 seconds. Drag it down, it gives you all the error. The mean absolute error is going to be the mean of these. How do I find the mean of these guys? I just take the average. So I add them all up and divide by the total number. I can do this in Excel. So that's going to be average is the command, and it's going to be R2 to R10. I'm going to take the average of these guys, and that's going to give me the mean absolute error. Mean square error is going to be the square of the absolute error and the average of those. That's R2 squared. And I scroll that down. And I calculate the average of these guys. And I don't have to do this again. I can just slide this formula to the right, and it gives me the mean absolute, mean square error. Obviously, the lower these numbers are, the better. On average, I have about 84 seconds of error from my prediction model, which is not really that terrible, but there's a huge spread in this. I also really want the standard deviation of this, but we're not going to go there. This is the minimum you have to know in this class, is how to calculate the mean absolute error and the mean square error. You need to know how to do this by hand. And to do this by hand, you would actually subtract your actual versus predicted and take the absolute value for the mean absolute error, and then sum them all up. In a lot of cases, you're only going to have one data point, so there's nothing to sum. You're just going to take the absolute value of those two. For the square error, you're going to do the squares of the differences and then sum them up and take the mean of those, the average of those. In most cases, you're just going to have one data point because you're making a prediction of just the next one. And so there's not going to be a lot to do by hand. We're going to talk about that in class, how to do these things by hand. But that's how you do this, and you're going to now emulate the same thing for your letters of recommendation data.